All right, how did you go with that challenge? Here's what I got, here's my result, and as you can see, the p-value is very small, so there is a statistically significant difference. And today we're going to finish up with the chi-squared, and after today's tutorial we'll definitely get back to the fun stuff, the visualizations. However, we do need to discuss one more thing in terms of statistical significance, and that is what to do when you have more than two categories in your variable. And let's get straight into it. We've got a variable here which is country, right? So how about we create we start a statistical test for country. So I'm going to copy this tab over here, just as we did previously. I'll rename it to country actuals. And now I'm going to take country, where is it, geography, replace gender, and let's make some room. Get rid of the label, and there we go. So we've got the actuals here. So I'm going to show you two ways. First, I'm going to show you the proper way, and then I'm going to show you my tricky, quick way that I like to use sometimes. So to start off with the proper way, you need to run a chi-square test for a larger table. You can't just run it for two categories. You need to run it for all three categories, and for that, there's a different website, which is valsars.net/new/cs.html. And what we can do here is input the values into here. We don't even need the actual totals for each category. We just need the numbers in the blue and orange squares. So let's just put them in here. We're going to go 4204. By the way, there's a quick way to look at this data as a table. So if you just go to show me and you click table and then you transpose it and then you make some more space, then you pretty much have the table ready, so that way you can't make a mistake when you're copying your values. So let's zoom in a little bit, and there we go. 4204 810 1695 814 and 2064 413. So calculate, and this chi-square test has been run for three categories now, and as you can see, there's the p-value. It's very small, and once again, that means that there is a statistical significance, meaning that when you go to the overall population, rather than look at sample, when you go to the overall population, you will also see an effect similar to this. You'll see that people who reside in Germany are more likely to leave the bank than people who reside in Spain or France. So that's how you should do it properly. But as you can imagine, as you get more categories, it gets harder to input that table. And moreover, this specific tool only has a limitation of 5 by 5, right? And you don't want to sit there and just input data all the time, especially when you can already see that there is a difference. You can see it here, right? So why should you waste your valuable time and input this data just to validate something you already know? You do need to validate it, but is there a quicker way? So I offer you my approach that I kind of like a lot, and let's have a look at it in a visual manner that will make a lot of sense. So here's our countries. So France, Germany, and Spain, right? What we're trying to do is compare these rates of leaving, or these chances of people leaving the bank for different geographies, and I want to say, is this a statistically significant result? So will this result be the same for the overall population? Right now we're comparing all of them. So we're saying, is in general the country you reside in an important variable? So my suggestion here is, why do we need to compare all of them? Why do we need to compare all three? How about we just separate one of them, like we forget about this part, forget about the or the people from the sample size that live in Spain, and just compare France to Germany, right? If we find a significant difference there just between these two categories, then that will mean that overall there is a significant impact. So basically we're saying that if people in Germany are leaving more have a higher chance of leaving than people in France, then by adding people from Spain, it won't change. They're still going to have a higher chance of leaving than people in France. Maybe there will be a different relationship to people from Spain, but we don't really care about that right now. What we're saying is that there's a statistically significant difference for this specific variable, and we can extrapolate it onto the whole population. And in a way, the way you can confirm that this logic is true is think of it as this is your test, right? You had people from France, people from Germany, and people from Spain participate in your test. Now imagine you had designed your test differently. Imagine you had designed your test in a way that you only looked at people from France and people from Germany. You didn't look at people from Spain at all. And you looked at exactly the same people. So do you think the result would have changed? Well, obviously not, because these people are not related in any way. And that's how your test is constructed, that there is no interdependency. So the decisions of these people to leave or stay with the bank is not affected by the decisions of these people. And so therefore, you can totally separate your categories. So you can, if you have many categories within one variable, like here, country, you can take any subset of those categories and compare them between each other using a chi-square test. And that is totally, totally fine. So let's go back to our worksheet. So here you can see that between Spain and France is probably not a significant difference, right? So why would you ever run a chi-square test between this and this, right? To prove something. Instead, let's run a chi-square test between France and Germany and prove that there's a statistically significant difference between them. And that'll be sufficient for us to say that geography as a variable is an important variable. It does play an important role in the decision of people to stay or leave the bank. And that's my handy trick. So that's our country. We've already done the test for country actuals, right? So this is the result we got, and it was statistically significant. Obviously, if we run this test now for France and Germany, we will also get a statistically significant result, and I'll leave that up to you if you'd like to check that. That's totally fine. The other thing I wanted to show you here is that if we now go to age, you'll see that there's a lot more categories here, and it would be a very painful exercise to run a chi-square test for all of them. However, you can use this as practice and pick out the categories where you think there is a statistically significant difference. I'll give you a hint, maybe 50 and 35 or 45 and 35, something like that. Any two where you can see it looks like there's a difference, and just run a chi-square test for those two. And that way you will have sufficient evidence to say that age is an important variable. And so that's how we validate the insights that we derive from this visual improvisation of our statistical tests. As you can see, it's not that hard, and in combination, those two methods complement each other. You can quickly get insights using Tableau, and then where you do suspect a statistically significant difference, you can quickly validate it using a chi-square test. And that's all for today's tutorial. In the next one, we'll get back to creating some more cool visuals, and I look forward to seeing you next time. Until then, happy analyzing.